Assume that a procedure yields a binomial distribution with the trial repeated n equals 5 times. Use some form of technology to find the cumulative probability distribution given the probability p equals 0.837 of success on a single trial. So a cumulative distribution. So this one, we're looking for CDF probabilities, cumulative distribution function. That's what that stands for. Well, I can use my calculator to find cumulative probabilities. So binom CDF takes 3 inputs, n, the probability of success on any given trial, and the number of successes that we wish to observe, which when k is 0, that would be 0. And then it gives me a probability, which this is written in scientific notation, but what it means is like 1.1506 times 10 raised to the negative 4th power. So that's just scientific notation. Same thing. Or if I change it to decimal notation, it would be like 0.0001506. Okay? And I'm going to take this and round it to 4 decimals as requested. So it looks like it would actually be 0.0002. Sometimes binomial probabilities are rather small. Okay, now, if I get the next one, then I could go to binom CDF and give it 5 for the first input, that's the number of trials, 0.837 for the next input, which is the probability of success, and then I could give it the last input of 1, but this doesn't look like it's going to be much fun because I'm going to continue doing this process over and over and over again to fill in all these probabilities. One thing that you can do is just give binom CDF 2 inputs, and it will go through and it will give you all the cumulative probabilities. So you can, in fact, scroll over and get the next one, so 0.0031. And then you can keep scrolling through and find the rest. But scrolling through isn't the easiest thing that you could do. So another thing that could help you out, or you could just go with this, that's fine. The output here is a list. And I know it's a list because it's the numbers are separated by a space and the start of the list has a curly brace. So I can put that into a list in my list editor and make it easier to see. And it's simple to do. The STO button stands for store an item someplace. So I want to store this list in second 1, which gives me the L1. So I want to put my list in L1. If I do that, I can now go into my list editor and get my cumulative probabilities there. And it will be a little bit easier to read. So my next one is 0.0334. Then 0.1892. 0.5892. And finally 1. The last cumulative probability should always be 1.